Okay, let's start again. The last session is about public transport. Thank you for staying here till the end. And of course, we have heard also before some words about public transport within other presentations, but now we focus again to public transport. And of course, we have heard that slab track was developed, the development started in the 60s of the last century. This is the truth, but it is not the truth, because in public transport it started much earlier. We are actually writing a book about slab tracks. There is one colleague, Lasse, he will hold the first speech, and two other colleagues and me, we are writing this book, and we investigated how long does it give these slab tracks. And we saw that the first tramway, which was built in the 30s, nearly 200 years ago, was built with tracks which comply to the slab track system. So even if you look to the norms and you look there to the point that you has a bound base layer and all these other standards, you see that this track work comply to the slab track norms and standards. And in Turin, here in Italy, there was written a book in 1860 roundabout, where a French engineer proposed 3 types of standard track for tramway systems, and indeed 2 of them comply to, to slab track. So we will see what we will hear now for the public transport session. Lasse, please come and start with the first session.
Yeah, thank you very much, Olaf. I hope you enjoyed your lunch and you're feeling energized for the last session. At this point, thank you very much at the organizing committee. I'm really enjoying the conference so far. And yeah, lunch was great, but it's not the only thing which was great. So thank you very much at this point. I will go into a polymer-based slab track like it's written here. The idea is maybe on this first slide, and I will go through that and show you what the idea is and what I'm doing at the moment at Technical University of Berlin. Of course, this, like Olaf said, slab track could be implemented into public transport and into high speed as well. And because the system is new and we know composites maybe not having or material quality is an issue sometimes, especially if you're inventing new material compositions. So first step could be in public transport because of lower axle loads and lower speeds, and that's why I'm going to present it to you now. So as I said, the first idea was when I was working for Deutsche Bahn at the high-speed line between Berlin and Munich. Much slab track was implemented or installed, and at the same time polymer sleepers appeared. And I was thinking about, in view of circularity, in view of resource usage, in view of elasticity, if it's possible to maybe combine polymer material, composite materials with slab tracks and implement it not just in ballasted tracks, but also in slab track. Genau, yeah, and now I searched for the durability. On the right you can see the slab track in Reda-Wiesenbrück, so the first one we heard for high-speed line. And on the left, a polymer sleeper we were working with. So the first idea was to kind of produce a whole plate, like prefabricated plates we heard before, out of concrete, and substitute the concrete by composites and polymers, and having a look what is working, what's not working. I did an FMEA, and yeah, it turned out that it's not that easy to produce a plate which has these big dimensions out of polymers or composites because of heating while the process, also some torsions when the plate is cooling down and stuff. And so the solution, the step was to go into a top-mounted system. We also heard some systems which got presented here. And yeah, asphalt has a good circularity. Also within streets, it's good reused. And so the idea was to substitute the top-mounted blocks with composite materials. So at all, we see on the right the 3 layers, the top-mounted blocks or sleepers, then the asphalt layer and the hydraulically bound layer. Then for the title is FE analysis, so finite element analysis. What you need for that are material data, or is material data, and thanks to good literature, Professor Freudenstein is here, so thanks for the work. I could have looked up many things. Also of Mr. Eisenman to asphalt layers, hydraulically bound layers, also elastic foundations, and in the guidelines standards of DB, and also the guideline 16,432. The Euro standard, European standard, and yeah, you can see these different material data here. On the top, I wrote down sleeper composites. As you may know, there are different producers of sleepers made out of composites or polymers. So it's a range often, because of course it's depending on the material mixtures, which, for example, E-modulus or Poisson's ratio is appearing. And based on literature, based on material data, there's a range between 1,500 and 7,000 megapascal in E-modulus, and what I found out, and a range between 0.25 and 0.35 Poisson's ratio, based on how the mixture is of these composites at all. Second, or the detailed material data. So what we did, we have a material which is combined, or which contains recycled glass fibers out of rotor blades, and also recycled polymers. And yeah, we did some testings also for dynamic ones, of course, with a specimen, so to get the material data. And on the right, you can see a Wöhler curve, and so our investigated material has a E-modulus of around 3,800 megapascal, and a Poisson's ratio of 0.33. And we found out with this dynamic fatigue test that around 10 megapascal is the durability, dynamic durability. So these material data got into the analysis. Then, as I said, I based on that what is according to guidelines, and there you can find the different loads per rail seat. So you can see the basis is of course the UIC 71, especially if you're going to high speed or to big trains, I would say. But of course, it's interesting to look at this dimensioning and maybe comparing it then, or transforming it to public transport as well. Yeah, you have for the dynamic safety factor and also for load factors, you can add these 1.8 spatial factors, and then these loads are appearing per rail seat, and you should focus on 7 seats. Yes, so the dimensioning at all is based on the beam on Winkler foundation because we're having this asphalt layer, and it was also transferred to railway by Zimmermann and then to slab track by Eisenmann. And it's interesting to get to know if the appearing tensions within the supporting layers by assuming the loads are lower than the durability of this material, and the same for the block which is on top or top mounted. These two parts were analyzed differently. And then also verified against the laboratory tests we did in the end, and to see if the analysis or the FE analysis is sufficient. So here are some results for the supporting layers. As you can see on the right, these are the two supporting layers. The load is applied directly on top of the asphalt layer because you want to get the tensions in the baddest situation, I would say. And as you can see, you can find the different material data here again, so the different composite mixtures, and also this one is concrete. And as you can see, for example, here at the asphalt layer, it is like when applying concrete sleeper with normal size. So in the first step we did normal sizes because we wanted to verify it against the laboratory test, and these were normal sleeper sizes. And when applying a concrete sleeper here, a tension of 0.39 and so on Newton per square millimeter are appearing. And as you can see, if using polymers with different mixtures, a bit higher tensions appearing in this asphalt layer, but they are all well below the fatigue limit or the durability of 0.8 megapascal. So as you can see, of course, it's rising a bit. It has to do with the load capacity or the load spreading and the elasticity of the block on top, but at all, it's well below the durability. Then second, the top-mounted sleeper needs to be investigated. And as you can see, the maximum tensions appearing within the sleepers are around 1.3, 1.4 megapascal or Newton per square millimeters. And as I showed you, the durability is at around 10. So we are well below this durability, also dynamic durability. And in this case, it will be durable. As I said, we also did the verification. As you can see, we have rail seats, so the current normal seating for polymer sleepers. I know Foslo is doing some research or is doing also producing with direct fixations, but at the moment for our lab test we had to use these rail seats, and we put on the maximum rail seat load of 100.08 kilonewton, which I showed you before, which is the highest load, and compare it to, so wanted to get the gauges, the strains. So we placed strain gauges around the seat, as you can see this picture also there, and got then the different strains around it and compared it to the ones appearing in the simulation, and we had a accuracy of around 3%, somewhere a bit more, but this was because of torsions. I have a picture, I think, later on. So some sleeper, or the sleeper had a small torsion, as I said, because of the cooling. Sometimes they're getting some torsions in it. So but at all it was around 3%, so good accuracy, which showed that this data we got could be transferred to real life. Also, second verification against the manual dimensioning, which I said is based on Eisenman and Zimmermann, and yeah, was quite the same, and this was then the basis for the results I showed before. So to do the verification against the manual dimensionings as well. So as a conclusion, we took the requirements of European Standard 16432, as I said, and the guideline of Deutsche Bahn, and had a look on that. Of course, this approved polymer sleepers could be durable within slab track system. Of course, you have to take a look on adapting the block, and also you need to kind of screw it down to the asphalt layer, so maybe just some blocks on the sole are not enough. You have to screw it down because of lower weight of the polymer to get all the resistance you need in lateral and longitudinal ways. But in combination, also weather resistance is of course a topic, especially if you're looking to the guidelines or also to the standard. You will need to, as you know, 60 years to cover 50 or 60 years, depends which one you are looking at. And it all, this is something you need to face, or this polymer sleeper needs to face, and yeah, of course, research is needed in this case. Yeah, so outlook is possibility to build circular slab track and a test installation. I also have it on the next slide. Some other outlooks, so viscoelasticity of asphalt layer and also the interdependency between the mounted top block out of composites and the asphalt layer could be interesting to investigate more. Also influences of fibers within sleepers and blocks, sometimes anisotropy. Also this could be or is a research topic for the future. This whole system could be tested in a laboratory test. Also these interdependencies between block and asphalt layer. Test installation, as I said, of course, hopefully not in high speed in the first time, but maybe then later on. And as I said, durability in view of weathering in combination with dynamic load for especially. And yeah, maybe adapting the design to public transportation like light rail. Then you need to have also the different surfaces and stuff like that. Could be something for the future. With that, thank you very much for attention, and I'm very open for the discussion later on. If you want to discuss before, just send me an email. Thank you.
Thank you, Lasse. I was studying at the same institute in technical university. That makes me happy. Okay, yeah, so now the next speech is about embedded rail fastenings. Rick, please come to the floor. Okay.
So, dear audience, first I want to give a big thanks to the organization for this event and the opportunity to present our ideas to you and to the world when this will be broadcasted elsewhere. And also thank you to the esteemed chair for the introduction. As representative of the edilon sedra group, I'm here to present to you our insights on the forum's main topic, of course, contemporary slab track design and construction, with our focus on slab track, prefabricated slab track elements. But first I'll share a quick word on my person. My name is Rick Monteban. I'm 60 years of age. I live in the Netherlands, and I'm married to my only and first wife for almost 30 years now. And we're almost 40 years together, if I may add. And I'm a father of two adult sons, of which one is still adolescent, I think. I've been working for edilon sedra for over 17 years now in some variety of roles and responsibilities, all related to business development and project support all over the world. Currently, I carry the business responsibility for Northern Western Europe, Middle East and Sub-Saharan Africa and India, where we make our first steps into that huge railway market, which is also very interesting and also very much aimed at slab track developments, if I may add to that. I do sincerely hope that I can get your attention after these 2 fully packed days and leave you aroused about our views on the slab track developments. It's not a very technical story, which might be just as comfortable for you at this time of the day, after the fully packed program already presented. This is more about our view on an appropriate approach towards slab track development and implementation, and a peek about our latest system development. It will also give you an overview of possibilities which edilon sedra can develop and implement together with you. In focused personal meetings, we can then go into the technical and also practical and economical details. Slab track or ballastless track, abbreviated as BLT often, has seen increased acceptance in the global railway market for all the right reasons, as also presented during the past 2 days, of course. On the screen you can see only a few examples of BLT projects designed and supplied by edilon sedra. And many other varieties have been presented during these 2 days as well. Here you can see a direct fastening project in Toluca, Mexico. This is in Rotterdam in the metro system, also embedded block system, tunnel installations with embedded rail, and also obviously urban track, and in this case with a mixed bus lane, which is always challenging to design and maintain. Finding the right starting point of any slab track development is of greatest essence. It has been addressed in a few presentations as well, and I had similar discussions with visitors here during lunch and coffee breaks. Project development for slab track and its design knows many stakeholders to become involved in the development and the further steps in development of the slab tracks. And this is not a non-exhaustive overview on the slide, of course. Early involvement of all, including expert parties, of which we are present here together as well, is of quintessence for holistic and all-encompassing and finally optimized and successful approach. It reduces the risk of later regrets from choices made, or maybe more importantly, of choices that were not made. Can only be made based on the complete trade-off matrix, combining technical, aesthetical, economical, environmental and performance requirements. Bias, opinions, preoccupations, assumptions, you all have experienced those from your customers or co-workers, form the ultimate risk of the final development of a slab track project. But it is a mutually agreed involvement, interpretation of those aspects that truly add value to the envisioned outcome. Slab track is developed by the edilon sedra for almost 50 decades already, and we built up a huge field of expertise for these applications. Also for metro, mainline, tunnels, depots, stations, level crossings, etc., and urban slab track at the same time. This vast knowledge and experience is being put into use via our application and engineering team and other supporting technical colleagues, and is also translated in technical support services with a focus on the appropriate application of the edilon sedra system portfolio. Also on that aspect, I discussed with a few visitors that has shown an interest in our booth, that we as a system house do supply systems that are validated, developed over the last 5 decades, but also the added value, as mentioned before by other companies, is a very important aspect of the collaboration. From design, testing, engineering, advice, project planning, execution support, etc. The whole package should be included to come to the right conclusion and the right execution of any project. Construction of slab track can be done in many ways, obviously. Also, our colleague companies have shown several possibilities to do that. The use of prefabricated elements becomes increasingly popular for many reasons. Although some advocate against it, often for the wrong reasons or interpretations or opinions, as mentioned before. And here, just a quick overview of some examples. Here you can see pre-embedded rail in steel channels that can then be casted in locally. Slab track for container terminals, completely pre-assembled level crossing elements, a complete embedded rail bridge that will be hoisted in, steel decks that can be prefabricated, and also urban track, as here seen in the city center of Birmingham, with turnouts included as well. Construction of the presentation is a little bit mixed up, as you have noticed probably, so I'll try to find my way through it. This overview shows a few other examples of prefabricated elements in different forms and shapes. In this case, you can notice prefabricated steel channels, either including or excluding reinforcement. And the smaller pictures beneath it also show that we can also include all kinds of finishing in the designs, which is elementary for urban slab track development. So cobblestones, asphalt, green track, you name it, it can be included in the design. And every question that you would ask, can we include this, can we include that, drainage, cabling, etc. Yes, we can, because it's all a design aspect. And then we have to discuss about where the drainage has to go to and which kind of cabling you require. This shows prefabricated concrete channels. Also the same background, all kinds of finishes, the surrounding dimensions, rail profiles can be included in the designs to your requirements. Also important to mention, there have been a few presentations about mass spring systems. In the edilon sedra portfolio, we do also provide mass spring system materials called track class range. You might have noticed that on the previous slide on our portfolio. Our starting point is actually to see if we can avoid a mass spring system by tuning the top fastening system and prefabricated elements. That's not always achievable, but we have one excellent example in Gothenburg, the Skeppsbron project, where we used a very elastic system for a tramway where we could avoid a mass spring system as a construction element, which saves reinforcement, which saves workforce, etc. So that's where we start in looking at our design collection. And then the full concrete slabs, typically suitable for urban track as well, with mixed traffic. Also here, all kinds of designs and inclusion of finishes are possible, either placed on leveled sand or grouted for inclinated track, for example, and also, as mentioned before, container terminals, depots, etc. Aprons can be built with these solutions. One of the commonly used edilon sedra rail fastening methods in BLT for both in situ constructed slabs or prefabricated element is the Cork-Elast embedded rail system for the beneficial properties it offers. On this slide you can find an overview of typically addressed elements as aspects for slab track construction and design. Not all of these on the list are always required to become a benefit, because if you don't need it, it cannot be a benefit. But what we also have learned, going through BLT project requirements, Cork-Elast embedded rail should be capable to tick off all the boxes for any project requirement as we speak. Edilon Sedra has now developed the next step of prefabrication of slab track elements. And this is the point for the presentation, to show you something new as well. We call it Edilon Sedra Embedded Rail System Modular, because we prefabricate pre-embedded rail sections, or modules. The process of conditioning, the installation environment, preparation, mixing of the components, pouring, curing, are all taken care of before the actual in situ installation takes place. This assures 100% quality supply. Nothing will leave the factory before it's okay. Consumption and cost are controlled, and time is also saved during installation, which is an often heard disadvantage of embedded rail, is the time of installation. Benefits of using ERS-M building methods of embedded rail combines typical prefabrication benefits as mentioned before, and a few more in addition to that, as shown on this slide as well. And what's an interesting aspect that we learned during the development and trial installations, that we also tap into availability of workforce, skilled workforce. And for installation of embedded track in situ, you need trained, certified people. For the installation of ERS-M, so prefabricated embedded rail, you don't. It must be people that understand track installation, but it must not be certified embedded rail installers. So that expands the possibility of putting a workforce on the project. With this newly developed and patented building method for embedded rail fastening in slab track, Edilon Sedra has made the next step toward innovative and sustainable slab track development. And here you see a few examples of what it could look like. And that's my presentation. Thank you very much for your attention.
Thank you, Rick.
Thank you.
Okay, so next speech is about solutions for tram slab superstructures. And the speaker is not as pronounced in the program. Here is Tomasz Szuba, but now we will hear Aneta Borovic. Was it correct?
Almost.
Close. Okay. Ah, you are both. Okay. You like to have this? Or?
Oh, we can like that.
Where's the pilot? Okay.
Buongiorno a tutti, or buonasera, I don't know what is correct now. Ladies and gentlemen, it's a great pleasure for me to participate in this railway forum in Naples. And on behalf of Tines Rail, I would to sincerely thank you for this opportunity to be a part of this event, which bringing experts and leaders, as I see, of all the world, not only from Europe. I am aware, but I was aware that when you will be look on the screen, you will see the names two gentlemen, but Olaf said immediately that this is not two gentlemen. Tomasz Szuba, our president, unfortunately cannot join to us today, but he sends you the best wishes, greetings, and me like replace it. So my name is Aneta Borovic-Barczuk. I am in Tines not so long from December, and I am international director. So please about understanding of all my mistakes. Today, our presentation will be given jointly with Mr. Michał Strach, the professor of the AGH University of Krakow, with whom Tines has been successfully work on research and development projects. The subject of our presentation regards solution for tram slab tracks structures. However, it's also worth to saying you about Tines' 20 years of experience in in field of railway surface, which bring conclusions for urban tram slabs.
Hello, my name is Michał Strach. I representing the AGH University of Krakow. I'm working in Department of Engineering, Surveying and Civil Engineering, so professional, I'm a surveyor. Well, I'd like to tell something about R&D in cooperation with TINES. The TINES technology creating durable track structure for railroad crossings consists of prefabricated concrete slab and an embedded rail fastening systems. To mark its 20th anniversary, TINES commissions the Railway Institute to run a nationwide in-service survey of railroad crossings. From 175 sites, the team selected 20 with the presented design and conducted a full measurement campaign at each. This team selected 20 crossings in different regions, covered about 3,000 kilometers in 10 days, and logged roughly 300 man-hours. A nationwide survey focused on railway solutions. A uniform measurement protocol at each crossing enabled cross-site comparison and highlighted the main durability drivers: slab roadway joints, drainage condition, and fastening system condition. At each site, precision leveling was carried out across the crossing and transition zones. Track gauge, cant, and twist were measured, and the slab's fastening system components, the slab asphalt joint and drainage, were inspected. This consistent protocol allows reliable comparison between sites. This is the sample, which covers diverse traffic and ground conditions, including high traffic roads and several double-track locations. This diversity increases the external validity of the findings. Across most sites, slabs showed no cracks, blisters, tears, or foreign inclusions on the running surface, and faces are protected with cover plates. Local issues were linked mainly to the slab asphalt joint and edge loading. The fix is straightforward: restore joint sealing, repair adjacent asphalt, and keep drainage effective. The slab roadway joint is the most sensitive interface we observed. Loss of sealing allows water and fines to enter, which accelerates edge distress in the asphalt and undermines support at the slab edge. Our recommendation is to restore sealing compounds, repair adjacent asphalt, and where needed, and include routine inspection of this joint in maintenance plan. Drainage is the most common weak point around the crossing. Missing channels or clogged rail grooves allow water and fines to migrate under the slab, accelerating edge distress and sub-base softening. Recommendation is to design and maintain dedicated drainage, keep grooves and inlets regularly cleaned, and include this task in routine maintenance plans. These photos show typical drainage weakness around the crossing, missing approach channels and clogged rail grooves, which let water and fines migrate under the slab and trigger edge distress. Our takeaway is simple: design dedicated drainage into the crossing and ensure regular cleaning inspection is part of routine maintenance. The elastometers serving as elastic mounting and support is generally intact. No cracks, delamination, or functional deformation were observed. Isolated defects point to deviations from installation procedures rather than a system issue. We recommended strict QA or QC during casting and bonding, with prompt local repairs. And this is, I think, interesting slide. We walked about this monitoring system a few years. We successfully tested at our university this telematic network. This is the concept of mesh telemetric network. The system is self-organizing. Infrastructure monitoring modules and person monitoring modules form a local mesh, and a gateway bridges the telemetry to the IP LAN for the end user. It can forward drone telemetry during flights and works independently of Wi-Fi or GSM coverage. Functionality has been successfully tested at our university, and together with D.Sc, we are adopting this architecture for infrastructure monitoring, including slab track settlement, deformation, and interface event.
So, why Professor spoken about the railway? We wanted you to see the results of voluntary tests which Tomasz made, and the many years of real-world operation of the railway solution, so that you could see how level crossing under heavy rail conditions became a true testing for ballastless track technology, confirming its durability, stability, proper track geometry and safety, and also, of course, LCC, life cycle costs. This experience with present and the future, I don't know what's happened, and the future implementation which Mr. Michał saw us, give us something extremely valuable. It allows us to transfer the approach and technologies proven in long-term railway operation into the urban environment, where track infrastructure must safely integrate with the city's public space. We are able to successfully carry over the strict railway requirements for safety, for repair construction time, long-term service, and additionally for vibration and noise reductions, what is very important in the cities, especially these old cities with the buildings, pre-war buildings, yes? So now we are going smoothly. What, in our systems, what connects the railway with tram? It's our polyurethane elastomers, which we produced in Krakow. We use them both on railways and in tram track systems. The Tines polyrail set consists of proven polymer and epoxy materials that can meet the needs of even the most complicated track infrastructure projects, and also, of course, customized projects, because we have got our own laboratory and our technologies are working all the time for improvement these products. Based on more than this 20 years of experience, we want to show you, for us, the best solution for urban environment. Show it on the slides. Tines Tram integrated tram road track system. It is a complete solution built upon railway experience gained during the construction of level crossing by Tines Rail, and of course adapted to in terms of performance parameters to the requirements of tramway operation. What is also connected? Of course, slabs, but not so heavy, with the less amount of reinforcement inside, yes. And embedded rail fastening system, Tines Tram ERS, based, of course, on this polyrace elastomers as presented earlier. Now, you can see that in our offer, we have got a lot of prefabricated elements used in tramway infrastructure, because often work under modernization conditions, which means adapting the existing infrastructure. Sorry. Here you can see the slabs for channels, for pipes. This is also always adjusted to the project, to the requirement of the client. The Tines Tram ERS fastening system is the first tramway fastening system in Poland to be tested and approved for operational as a complete structural solution with verified and certified system parameters, according, of course, with the norms. Described solution for urban infrastructure fits very well into the urban landscape, what is very important, of course. The slabs doesn't not have to be heavy, ugly, or crude, like everybody thinks when we say the slabs, the concrete slabs. Everybody think about something, I don't know, simple. So, of course, the slabs must be appropriate technical parameters, providing reliability and safety in the same moment. To conclude, we prefer slabs with shaped rail, already shaped rail channel, because this technology reduces installation time. Generally, after 24 hours, we are able to reopen traffic on the prepared section distance. As a proof, we want to show you some movie, some short movie on the end of our presentation to illustrate the key advantage, which I said a few seconds ago. It means the ability to very quickly rebuild a tram road crossing. And this example we're calling the weekend metamorphosis, transformation of tram road crossing in Gdańsk. Generally, on the end, we believe that the future of sustainable mobility relies on the integration of railway and tramway infrastructure built on shared experience, materials, and best practice. And in our view, rail and tram system achieve the greatest potential when they will be grow together. Thank you very much for attention.
Thank you both. Thank you very much. So now is time for the last speech. It comes from Zagreb and it is about innovative fastening systems. It is held by Franka. So, nice. You like to use
no,
this or that?
this one.
Okay.
Yes. Thank you for the introduction and for the chance to present at this wonderful conference. My name is Franka Meštrović. I'm coming from University of Zagreb, Faculty of Civil Engineering. Currently, I'm employed there as a research and teaching assistant, and I'm also doing my PhD, and this is the current topic, current research I'm doing. Today, I will present the Zagreb 21 STT slab track structure used for urban tramway construction. I will begin with a bit of an introduction into the Zagreb tramway system. Then I will describe the Zagreb 21 STT slab track structure. I will explain the test section we did 11 years ago and current implementation in Sarajevska Road. I will also present some future plans for my research and in the end concluding remarks. So, as far as Zagreb tram network goes, total length is 116.3 kilometers. On this photo, that is the bluish hue, the purplish actually lines. And every day, 180 trams are on the network. We have 15-day and 4-night lines. When we're talking about the substructure, 94.1% is reinforced concrete slab track. It's approximately all over the network 25 centimeters thick. Rails are discretely supported and sleeper spacing is every 1 meter with the track gauge of 1,000 millimeters. On the photo you can also see the red lines. They are representing the planned tram lines and 2 of them are already in construction. And the green lines represent the long-term projects which are planned in the next 5 to 10 years. Now I'll start with how and why we developed, my colleagues developed the 21 STT system. In 2005, that was 20 years ago, a big rolling stock renewal was happening in Zagreb, and this tram on the photo was first introduced. It's TMK 2200. It's built by Končar. And before that, all tram slab structures were designed for a wheel load of 20 to 25 kilonewtons per wheel. However, this tram had a load of 33 kilonewtons per wheel, and obviously that introduced some main changes, such as increase in the axle load, different load distribution on the structure, and due to different wheels being used, change in geometry of the wheel rail contact happened. So all of that, considering that track structure remained unchanged, obviously introduced some new effects, which included increased rail wear, that are the bottom 2 photos, so a lot of corrugation, unevenness on the rail head, cracks, especially in the zone of welds, etc. And next to the increased rail wear, we noticed some accelerated degradation of track geometry, and that was due to the failure of fastening systems and rail supports. Unfortunately, I was unable to find better photos than those 2, the top ones. So considering all that, the infrastructure manager noticed that a change had to be made, and in 2013, they requested the development of an adequate fastening system, which would take into the account the main reason was the increase in the wheel loads and then the traffic loads. There are some segments on the network that have up to 15 million gross tons per year, as well as traffic frequency. So some sections experience intervals less than 90 seconds, sorry. And also, of course, the strict tolerances related to track geometry and track gauge. They gave the Faculty of Civil Engineering the opportunity, and my colleagues, professors, considered 5 fastening system options. In the end, 2 track structures were actually further developed and researched. Those are these 2. The left one is 21 CTT, classic tram track, and the right one is STT, slab tram track. I will shortly describe each one, but the focus is on the slab tram track. As far as the CTT structure goes, C stands for classic. Classic is in regard to the Zagreb 3/2 PP fastening system. So that's the most used system on Zagreb's network, and this is actually an upgrade. So the idea was to use easily available and standard railway components, and the main goal was reduction of noise and vibration, as well as protection against stray currents. This system is actually most suitable for reconstruction of existing slab tracks, considering that it's quite similar to it. So a lot of infrastructure managers, their project leaders and workers are quite familiar with it. Also, it's used in road-rail intersections because it's suitable for switches as well as terminus areas. I'll show you in a bit what I meant by that. Here we can see a 3D model of the structure. Bottom right is the ribbed plate with vulcanized pad underneath it, and in the cross section we can see that underneath the rail there is a neoprene pad. It's placed on a ribbed plate which has another level of elasticity, so a vulcanized pad underneath, and then it is placed on a bearing pad and fixed indirectly with anchor bolts. On the other hand, we have a direct fastening system, that is Zagreb 21 STT structure. It was based on a few track systems, but mostly on REDA 2000. It is a structure with prefabricated double block concrete sleepers, and it's especially suitable for open track segments where higher speeds can be achieved. When we're talking about trams, those are still not the higher speeds we usually consider in railways. So this REDA 2000 system was actually adjusted considering the track geometry, so a 1000 millimeter gauge, loads which are much less than on classic railways, as well as vehicle speed. So average speed in Croatia for Zagreb trams is 40 kilometers per hour. In the cross section we can again see the rail and the neoprene pad. They're placed on a discrete concrete sleeper, and rail is connected to the sleeper by a fastening clip and angle plate, and finally with Terfon screws. One of the big advantages of this structure is that it is prefabricated, but it can be also pre-assembled. So it can be pre-assembled in 18-meter segments with the corresponding fastening systems, and then later on delivered to the construction site. And the colleagues also developed certain tools for adjusting the track alignment. Before it could be implemented in a real case scenario, it had to be tested. So in 2014, 11 years ago, they built a test section in Savska Road. It's quite frequented by tram and car traffic. 3 separate tracks were built. So the PPE, that's the classic reference track, which was most used in the whole Zagreb network. Then CTT system and STT, approximately 53 to 59 meters in length for each test section. Monitoring wasn't continuous, so it was periodic. These are some photos from the construction site when the first implementation was being done. I would like to emphasize that this was more familiar, like I mentioned already, to the infrastructure manager, to the project leaders, as well as workers. So there weren't any significant problems during this construction of this section. While for the slab tram track, it was a bit challenging because it was the first instance of this type of structure being built in Zagreb, in Croatia. So the idea is, I think you're all kind of familiar, but I'll just mention that on a hydraulically bonded layer, 5 centimeters thick, sleepers are spaced each at 80 centimeters, and then rails are positioned on the neoprene pads. Fastening system is built and is positioned, and when track geometry is achieved, then the concrete is being poured. Furthermore, it was, like I mentioned, measured, so certain measures were taken immediately after installation. That was 2014, then 7 months after exploitation in 2015, and after 4 years of exploitation in 2018. By that time, almost 40 million gross tons had passed over the system. Apart from visual inspection of the concrete slab and the bearings, fastening elements, rails, pavement, and elastomeric pads, some other measurements were taken. So we measured, my colleagues measured track geometry, well geometry, stresses and deformations of the concrete slab. They used strain gauges for that, and on the top 2 photos, I circled the rebar which was used for positioning the strain gauges. Also, they measured the dynamic properties of the track, so TDR, vibration damping by using accelerometers. Again, on the bottom photo, we can see their position, and there's a shaft next to the tracks where they reached to get the sensors. And of course, the noise generation was measured. I didn't want to put too many graphs because my presentation is last, and I think you're kind of already had a lot of information, but the basic conclusion was that the D.Sc performed the best. So CTT was quite similar to the PPE. I put here, of course, the best results, but I have to emphasize that all the measurements were within the limits which were proposed. So, for example, increase in track gauge of 1,000 millimeters for PPE was 1.18 millimeters, while for the STT it was 0.92. As far as the maximum stresses go, longitudinal and transverse, again, STT had the best results. For the PPE, it was 3.33 maximum longitudinal stress, and for STT, 0.86. As far as the track decay rate goes, we noticed rise, so due to the settlement of the structure, the values were getting better and better, but overall, vibration damping from the STT system was most favorable. And as for the noise generation, STT slab system lowered the noise levels by 2.9, almost 3 decibels. So considering all that, like I mentioned, CTT was an upgrade of the current Zagreb PPE system, so results were quite similar, but STT exhibited the best results regarding specifically track geometry, maximum stresses, and noise generation. Equally means that property was similar to the PPE, while plus means that there was a positive improvement. So focusing on the STT, we can see that vibration propagation was similar to the existing PPE system, while the best positive improvement was in regards to the cost of the system and durability. When we're talking about installation speed, maintenance, protection against stray currents, and noise propagation, positive improvement was noticed in regards to the reference system and in regards to the CTT. Following all those tests and measurements, the first project of these red lines which I mentioned, which is currently in progress, is the bottom one. It's called Sarajevska Road in Croatia, and the construction started 10 months ago. So in March, it's actually the first expansion of the tram network after 20 years. So the first new tram tracks are being built. The total length of the section is 2.4 kilometers of tram track. Here are some technical details. So the minimal radius applied was 18 meters and maximum slope 35 millimeters over a meter. Along the tracks, 8 tram stops will be built, as well as the new terminus. and 4 switches are going to be installed. As for the track systems which are used, the reference PPE system is used in the beginning, so here, in the area where the tracks are connecting with already existing tram loop. CTT system is going to be applied here, so at road rail crossing, and here in the area of the turnaround. And the STT system is used at the 88% that is left. The CTT is going to be also used here. I would like to emphasize because, as maybe you saw here, a new line will be built, hopefully soon. So it will be much easier to connect the new line with this already existing one. As for the implementation, the calculation was obviously done for the load-bearing capacity of the track structure with proper wheel loads this time. 23 thick slab was considered. It was 200 centimeters wide and 40 meters of length. Selected sleeper spacing is this time 80 centimeters, while before in Croatia, in Zagreb, it was 100, it was 1 meter. And I would also like to emphasize that this new slab is actually reinforced with additional polypropylene microfibers. So on every cubic meter of concrete, 5 kilograms are added. These are some photos from the construction site. We took our students there last week and they had a really interesting time. So again, the construction is the same. Hydraulically bonded layer of 5 centimeters, every 80 centimeters placement of a sleeper, and after that, positioning of the neoprene pads and rails, positioning of the fastening system, and once the track geometry is satisfying, the concrete is being poured, as we can see here. And here is an example. So this area, this is one segment of the slab track which has been poured. This is next. So what is next for us? This is kind of considered in the project Eurythmis. The final goal is to implement digital twin technology for predictive maintenance of tram tracks in Zagreb. Project has been going on for 4 years so far. And the idea is that real-time vibration data is collected in the past 2 years from an in-service sensor-equipped tram vehicle operating on the network. So we have one tram operated and it switches lines every day. That way we cover the whole network. The idea is that large data sets, machine learning techniques, and digital twin technology will enable us detection of irregularities and defects at various stages of degradation, and thus will lead to predictive maintenance. And a little bit more about future plans. So the next step would be intelligent sleeper or smart sleeper. These are some cross-sections. We are thinking about equipping one sleeper with accelerometers, strain gauges, etc. Those will be the information for the numerical model. We're thinking about placement of the sensors, obviously mid-span as well as on the bearing, and position of the sensors in the track alignment sense, so nowhere near the traffic stops or tram stations, etc. The idea is that this, so track instrumentation combined with in-service tram, will give us far more comprehensive insight into track behavior. Apart from that, my current work is in progress. I'm building a numerical model of this track structure. These are just some screenshots, and the verification is in progress. So the idea is to define which parameters will influence most the behavior of the slab track system. We're thinking about varying slab thickness, stiffness and damping coefficients, as well as sleeper spacing. And next steps are obviously model calibration using the data which will be obtained during this smart sleeper or intelligent sleeper integration. And the last step is model validation, where some scenarios will be done in order to see how the structure's capabilities under new conditions. So, concluding remarks, the system, after 10 years of monitoring, shows as durable and resistant. The option of prefabricated sleepers and modular segments is efficient in installation and maintenance parts. Heavy frequent traffic is a bit of an overreach, but it could be ideal for urban tram networks. And so far, successful deployment along Savska and Sarajevska show possible scalability and cost effectiveness. Again, the idea is to integrate digital twin technology and continuous monitoring, and that will lead to enable us predictive maintenance, which will then again lead to cost reduction, increased operational safety, and improved comfort and reliability of transport. So thank you very much for your attention, and hopefully we can discuss a bit later.
Yeah, thank you very much. Very interesting. So now we come to the question section. Are there any questions from your side? No question at the moment. Everybody will go to home. I have prepared some questions. Let me see. Yeah. Do you see any conflicts between innovative materials and standardization or certification framework currently in use? Yes, please. But it also fits to the other. You can start.
Of course, you need certifications. That's what I wrote down. So we are having composite materials in use at the moment. So also in Germany and all over the world, they are having certifications. So it's possible to get these, but of course, as I said, you need to take, for example, weathering into account, and this, I would say, baddest situation, having hot summers and high axle loads, dynamic axle loads, is very influencing the composite materials, and this is what you have to check. But yeah, there are certifications for that, and of course, this is the basis. Yeah.
Okay, fine. Thank you. Another question to the university part is, what role do universities and industry partnership play in accelerating innovation in tramway track design?
Sorry, could you repeat the question? I heard only the last part. Sorry. Yes, please.
The question is, what role do universities and industry partnership play in accelerating innovation in tramway track design?
Well, from my experience so far, which is I've been only working for a year in the faculty, so I think that definitely it is collaborative. It is a way to go forward, but it's very crucial to combine those two. So a lot of technical knowledge from the actual management of the track structure, plus the theory and the development of certain knowledges which maybe aren't present in the track infrastructure management.
Okay. Do you also have an opinion to that?
We very often want to get any grants, and we need cooperation with industry. So it's a good idea to cooperate with any company. We must do it well. Yeah, thank you.
Okay, thank you. Any other questions from the audience? So if not, I would propose that we make a short break, 2-3 minutes only, so it's sufficient time to go to the toilet, but not to go outside. We will then start with our podium discussion. The name is podium discussion, but you are also invited to discuss with us. We have to prepare 1 to 3 minutes something. Thank you. Der sieht immer die Farbe und dann schaltet er uns ein. The green one. Okay, we are close to be ready, so please don't leave the room. Please stay here. We now please the 3 people to us who are participating on the podium. Wo sind denn die Kollegen?
Stefan hat keine Stimme mehr.
Stefan, ja, der muss da durch. Matthias und ich kenne die beiden gar nicht hier.
Ist der, da steht.
Ja, okay. Stimmt. Du warst ja Matthias, ne? Ja. Da kommst du auch schon hoch, ja? Eben das schon mal. Ja, uns heute noch nicht geschüttelt, genau. Ja, jetzt fehlt nur noch einer.
Warte mal, lass mich schauen. Stefan, Manuela.
We were looking for you. Yeah, nice to meet you. You three go in between. Stefan geht ihr in die Mitte. Da sitzt dann Bernhard. Also wir beide gehen außen und ihr 3 in der Mitte.
Okay.
Ein Stuhl zu viel ist dann, ne? 1, 2, 3, 4, 5.
Einer weg.
Okay.
I have no voice, so I let you talk. Okay. Hi, Stefan. Okay.
Okay. Dear colleagues, we can start again with our podium discussion. Are you all ready to come in? Please introduce you for a short moment. We have had presentations with the name on and everything, but now they don't see any presentation, so it makes sense to say 2 or 3 words to yourself. Okay. Okay, we can start now. We have on the podium, we have 3 people who spoke in the speeches before, but now we don't have any screen with the names and so on, so therefore I would like to ask you to introduce yourself for a short moment that people know who you are, and then we start with the discussion.
Thank you. Stefan von Boon, Romberg-Sursa. I have a shitty voice, I'm sorry. I'm responsible for superstructure products at Romberg-Sursa since 2 years, and I'm very much interested about further developments of slab track and would like to talk life cycle costs.
I'm Marinella Giunta from University Mediterraneo of Reggio Calabria. I'm an associate professor of road railways and airport. And in my research topic cover all aspects of rail transportation and also the rail track, technical and environmental aspects of rail track.
Yeah, my name is Matthias Hofmann. I'm working for the Brenner Base Tunnel, BPT-SE. It's the client who is responsible for building the Brenner Base Tunnel here between Austria and Italy. And yeah, I'm at the BPT for 11 years and coming from tunneling engineering, but now we move to railway equipment in the next years.
Okay, fine, thank you. So, Bernhard, you prepared also some questions. Will you start with the first question, maybe?
Well, good afternoon, everyone. The podium session is planned that we would try to answer as much as open questions still from the seminar. So feel free to raise your hand and give us questions to the audience. We have experts from projects on the podium. We have experts from a special slab track construction on the podium, as well as the environmental aspect. So I think we covered more or less all of the seminar participants today. But to give you a chance to rethink about the good question, I would like to raise the first question to my colleague on the left side. Who is responsible for this very big project like the Brenner Base Tunnel. So my question would be from the first idea to the finish of a railway tunnel in this dimension, it sometimes takes decades of years. So can you give us a short timeline of the certain steps and of the Brenner Base tunnels? How long did it take from the first idea now to the construction? And do you see do you have any idea how to improve the planning and construction phases in the future, that the project do not take so long? I also remember Stuttgart 21 and all of these projects that take much too long. I think even in the public it is well known that we have to be more quick to come to the market, let's say it in this way. And do you have any idea, or could you tell us where do you see the most problems? Is it the authorities, or is it the homologation, or where should we improve to get quicker to new railway infrastructure?
Yeah, the first thoughts about building something like the Brenner Base Tunnel started last decade at 1970, so sorry, something like that. There were different ideas. There were ideas making a tunnel from Munich to Verona in once, which was more a fantasy than a real project. And then in the 1990s, there were several track studies where the tunnel could go below from Innsbruck to something for Dessa or Brixen or some Bresano or something like that. These were first studies, and the first decision to make something real started at the end of last century, so in the 1990s. And then with a general agreement between Italy and Austria, it speeded up something like 2002, 2003, there was a contract between the states, and so it started. So the real project realization phase, beginning with the authorization and so on, takes something like 30 years. So I think that's quite a common time span. It's a funny fact. The where the breakthrough was, there was an interview from a politician from 1990s in the media, where he said, yeah, if we try to push up, we will get ready in 10 years. So the problem is that there are fantasies at the beginning that we can fast and so on, and the reality is the other thing. Where I think time is lost, it's the authorization phase. Yes, that's a long time. It was the first one from 2004 to 2007, so it's 3 years. We have a second phase now, which hopefully will be only 1 year, but it's in parallel, we don't lose time. And the other thing, if you have large contracts, you have large legal issues sometimes, so it's also a question of the legal situation of the contracts. Are there better contracts in civil engineering? There's a lot talk about these partnership contracts. Maybe this would be a way to work more together, partnership, to force a partnership and to put less energy in legal discussions, and so some time could be saved probably.
Yeah, okay, thank you. So are there any additions to this issue from the audience, for example?
I might want to add that, yes, contractual issues are a big topic in these huge projects, and we are currently making quite good experiences with the so-called alliance projects, project alliances, like in the NWC project, Neues Werk Cottbus in Germany, or Gäubahn or Ball, the Fehmarn connection, because, like you said, the energy is being put towards the direction of where we want to go, and it's less fighting. But this is the concept, and the concept is relatively new, and people don't change from one day to the next just because now they work in an alliance project. And so it's a change, yeah. But the idea is good, and we see, even though it's a new concept for us as well, that people, once they get used to it, they like it, because it feels more like teamwork, yeah. And you are pulling at the same string and not in opposite directions. Yeah, I think that's very important.
Okay, next question is, how do you see the role of slab track evolving over the next 10 to 20 years? So we saw many good examples from new build slab track projects, and we saw some not so good. So what is your opinion about the situation?
Improvement of slab track.
Yeah, how will it develop more for the future? In what direction will it go, and how will it be, and the good and the bad experiences, what is the influence of these experiences to the future?
I think the experience, the wide experience of the application, the construction of a slab trap over the world can offer the possibility of of apply the slab track also in different contexts with respect the usual context of slab track, channel, tramway. I hope it can be also used in the open track. It's important to address the two main aspects, two main issues that slab track represents, the costs, mainly costs, and also the environmental aspect. I discussed about it because the optimization of the environmental performance in general of the railway system, but in particular of the track, which is a component of rail system, is important. This is also an imperative also from European community, because the transportation sector produces 25% of the carbon emission over the world. The 74% is due to the road traffic. The 11% is due to air transport and maritime transport, and only 4% is due to railway traffic. So railway system is a sustainable solution. In fact, when we talk about the sustainable mobility, the sustainable mobility for the future, we discuss about transfer the traffic from road, passenger traffic, but overall freight traffic from the road to the railway. It's possible to optimize the railway system, improving this its environmental sustainability. This requires to optimize different aspects, infrastructure, rolling stock, energy supply. But regarding the infrastructure, it's important also to optimize the track. We discussed today, in these 2 years, we discussed about the track, in particular the slab track, a particular type of track. So it's important to do the improvement also in the slab track. I think if the further technical improvement, economic improvement, and environmental improvement can be done in the present for the future, the slab track system, I think, will be the track of the future.
I think I would like to see for the next 10 to 20 years that we think not anymore that we can build and forget. Yeah, this I think is really important. It also adds to your topic of sustainability. We need to use new materials like Mr. Hansen was presenting. Polymers, for example, could be interesting. I actually see slab track made of plastic as a smarter solution than sleepers in ballasted track, because there's not so much abrasion going on. Yeah, all the plastic sleepers we put in the tracks, they get for sure abrasion, and then you have microplastics again across kilometers of track in your nice nature. So I'm not 100% convinced that this is a good idea. But for the slab track, I think there could be some benefit in it. And also, there was mentioning in the sessions yesterday of mechanizing slab track construction more. Because if you look at pictures from the 19th century where there was railroads constructed manually, and you look at pictures of railroads being constructed now, if it's slab track, there's still a lot of people there. Yeah. In ballasted track, we have the big yellow machines. For slab track, we don't really have them. There is reasons, but also we need to take into account for slab track, we have had only 70 years of development, and ballasted track, we have had 200 years or something like that. Yeah. So I think there is a lot of cool things still to do. So I think the future is looking good.
For sure. You like to add something?
What I found interesting is I'm coming from tunneling, and there's a huge trend at the moment regarding the concrete, which fits up to your presentation, that for the tubings, which are also prefabricated lining elements, in the UK and in USA especially, there's a trend that they only use steel fiber concrete anymore. They don't use bar reinforcement. And what's surprising is that they say that they can reduce the amount of steel by the factor of 2. So I'm not so deeply in the prefabricated slab tracks, but it would be interesting if there is a hybrid component that they mix it, like you presented it, a partial substitution, or even more if there could be steel fiber reinforced tracks in a way, or other reinforcement like carbon fibers, which, for long ways, for several kilometers or 100 kilometers of track to be installed, it pays every kilo per meter you save in. So that would be interesting from a constructive point of view to my view. Yeah.
Yes, these are all influencing figures, but how is it with standardization? That's a big issue which I miss. What's your opinion to that?
But I think there is a lot of investigation done already in most of the infrastructure managers. So we are starting, especially in Austria, but everywhere in Europe, the next year, the green steel. So the green steel will reduce the CO2 emission by 25% in all countries. We have also innovative fastening systems where you can reduce, which are already produced with a much less, with a reduced CO2 emission than before. And even in the concrete, I think every country has now investigations or projects running to change from cement 1 to cement 2 and so on, to reduce the clinker in it. So around 20 to 30% reduction of CO2 is possible. And we have already implemented it. And next year we will put on our tracks only sleepers with reduced CO2 emissions. So I think that, and this is done in every country, also in Germany, and they are thinking on this. So I think the most developed step of the next development will be how to bring it in a circle of life. All the components, all the track components, the rails going, when they have end of life, how can we put it again into the system? Probably not in the railway system, because if the material is no more strong enough, but we can put it in another field of application, all components, and I think this will be the future, even in the slab track system.
What is the opinion in the audience to these issues?
I wanted to add to the standardization, because I think, of course, you need standards, and we are having the European standard, but I think it's critical to describe a slab track by centimeters or something like this. So, for example, if Romberg-Serser just got a permission and is looking quite different than other top-mounted system, for example. So, because of that, my question is, if you're saying like we need more standards, do you want to describe a slab track, how it looks like, or yeah, maybe discuss?
Yes, more in relation to how it looks like. For example, I absolutely agree with you. We should not make wood of standards. But, for example, especially in public transport, we have, look to Reda. We have Reda City Berlin, we have Reda City Dresden, we have Reda City blah, blah, blah. Yeah. This is, okay, this is nearly the same system, but we have developments from other competitors which are similar or different, and then many transport authorities are developing their own solution, and every city is doing standardization for its own transit area. But it is not standardized Germany-wide or European-wide. So I think from my point of view, the producers can lead maybe a little bit to a standardization. So maybe this is a question to you.
We have discussed this already plenty of times. The things that you said, there is a system. If you go to public transport, almost every major city has their own system, and many of these systems are tied to the people who work there and who co-invented them or something, you know. So if I go there as a construction company and tell them what they should build, I'm not gonna get a contract. So in the end, the person with the money and with the decision power will say what they want to have. It's like if I want to tell you to wear a gray suit, you know, like I want to standardize suits now. Suits should be gray. So I will force you, Olaf, to wear a gray suit, but I want money for it. I think that's difficult, to be honest. But I do see merit in standardization if we can try and agree on something like a platform, you know? Thinking about, I mean, it's always a bit of a far stretch to go to automotive industry because automotive is very different, but we can learn something in terms of what they do with platforms where the vehicle from the outside looks very different, but underneath, under the hood, there's a lot of the same components. Yeah, I think this is something that could be done from a manufacturer point of view, and then everybody still gets a solution that looks like a black suit, but underneath it's a gray suit that was just painted black.
Lasse, that was exactly the answer to your question.
There is a question over there.
Yeah. Okay, please.
Hi, Barnaby Temple from Romberg Sursa. So I'm going to answer a little bit of the question, then I'm going to ask another one. So the first one is you're not going to stop innovation. You see the range of product ideas. They're not just coming from manufacturers, they're coming from academia and new people coming into the market. And the need is there, because that's the only way we're going to get the new materials, the new ways of doing things, is by innovation. So you can't have standardization means everybody does the same thing. I agree entirely with you. But I'm interested to ask a standards question. I have a view, but I'd like to ask the question first, which is, I'm on the working group for the Euronorm 16432. There's a couple of others in the room. If I look around, there were at least 3 others in the room before. Stefan is one, Paul is another, Julia as well. And we've just completed pretty much the editing of part 4, which is concerning noise and vibration, special applications for ballastless track systems. So the question back is then, what should part 5 be? So part 1 is general requirements, part 2 is design, part 3 is acceptance, which means acceptance on site and quality control, that sort of thing, not product acceptance per se. Part 4 is because we knew that there were some specifics around things like mass spring systems that combine these things. What should part 5 be then? Because I'm thinking from some of the discussion today, environmental sustainability type questions, or maybe it should be maintenance and repair questions. Would be interested to know if anybody else has an opinion on standards, what would be a useful next part of a ballastless track European norm?
Are there any from the audience who would like to answer to this question? Lasse again. Paul.
Thank you for the question. just thought about what's the case with ballasted track. So if we compare it, I would say, of course, at Deutsche Bahn or all the different operators are having their standard sleeper, standard height of the ballast and stuff like that. But if we're going to public transport, I would say there are also different sleepers in different cities, different countries. So yeah, I think it's, like you said, do we really need this standardization, which is also like limiting innovations? Yeah?
I'm Ivana Avramovic from POD. It's interesting because sometimes when it comes to the topic of fiber-reinforced concrete and implementation in Europe and on European networks, a lot of the times what we hear from clients is, okay, but there are no standards against which we can check if it fulfills the criteria. What is the criteria? So we as a company have implemented tunnel lining on projects in Asia with fiber-reinforced concrete. We were able to cut CO2, and the clients there were open to us working with that. But when we come back to Europe, the question is not, can we do it? Is it doable? The question for the client and the challenge for the client is, I don't have anything against which I can responsibly say, this is an okay method, this can work in our network, even though it's been proven in another one, I have to refer back to EN or something else. So I think it's a little bit of a chicken and an egg on how to start that in Europe, what comes first. And with any innovation, my personal belief is you have to have someone brave enough to take the risk. And if it works out, they'll be, oh, they did this great, they're the first, we can learn from them. And they don't want to be those where it doesn't work out. So it's easier not to take the step and carry on. But I think, especially with the topic of fiber-reinforced concrete, the standards are not necessarily for like what we as construction companies and component suppliers, it's not necessarily something that we have to push, but we need clients to say, and the standardization is not to limit us, but so that we have something, again, like it's kind of like a gate we have to pass, so we can have a certain solution implemented.
I want to somehow address Barnaby's, yours, and Lasse's things, or you want to? Sorry, I didn't look at yours. Okay. The thing is, first I was thinking it could be something about dismantling or so, yeah, and thinking about closing the circle, like Mr. Knoll said. But then I thought, why should we always add something? Because actually we are, what you just described, Ivana, is very much describing that, yes, we somehow need standards to be referring to something because it gives us safety and so on, and it's a liability issue. But also we are locking ourselves very much in with all of the standards that we are setting, yeah? And so maybe we should ask the question, which standards can we actually throw out the window? Or maybe we should rethink the way standards are being let's say, maintained. Maybe we should have a cycle of every 5 years. We look at the standard and say, can we actually chuck it out the window? Yeah, there is a cycle, but generally I don't feel that we are getting less standards. It's like entropy, it's only increasing, you know? And everybody wants more rules, and the rules make work very difficult sometimes. My opinion.
I would like to ask our professor from Reggio Calabria, what is for the future, what is the idea of Italy to push forward or to bring the traffic from the road to the railways. I remember there's a big hub in Verona. All the trucks coming from the north, from Germany, are changed there from the railway to the road, and then the whole traffic goes from Verona to Sicilia only by truck or something like this. So is there any, you know the Italian situation, is there any idea of improving this situation to bring the goods also to the south and not stopping it in the far north?
Yeah, this is a good question because the possibility to transfer the traffic from road to railways needs that the railway network is adequate to the new traffic. In Italy, there is this situation, the high-speed network ends to Salerno, and from Salerno to the end of Italy, and in Sicily, there isn't high-speed, but there are many projects for the improvement of the railway network. It's in construction. The first lot of the Salerno-Reggio Calabria high speed, but from Salerno to Reggio Calabria, the line from Salerno to Reggio Calabria is 400 kilometers. Now is under construction a lot near Salerno, and it needs, I think, many years to improve this line, to construct a new line, a new high-speed line until Reggio Calabria. The topic of the improvement of railway network is also linked with the construction of the bridge over the Strait of Messina, because from Palermo to Norwegian there is a corridor, TEN-T corridor, and railway lines belongs, some lines of the railway network, Italian rail networks belongs to this corridor. This is a question in discussion, but not all in discussion. There are projects that are finalized to improve the railway network and to make this railway network suitable for new traffic and overall for freight traffic.
So let's use the last 3-4 minutes for a question from the audience. We are on time if we finish in 3 minutes. So maybe, yeah, please.
Giuseppe Bomben from DTS. I'm a bit an outsider here in this concrete world of slab tracks. I can fully understand. I think that one thing is to think about where is needed. Where is needed the slab track? No way. Maybe you have a solution made like the gentleman from Poland or from Zagreb. They try out their own view to build it. And then there are a number of builders or other kind of solution, like the Lego one was the most impressive for me, at least yesterday. And but the real, comparison is to make not where it is necessary, but where nowadays you have the ballast one. So if I were in your shoes, I will point out, like I've mentioned yesterday evening and also today during the coffee break, point out the money, because most of the audience not here, of course, do not understand the newtons, megapascal you can imagine. Maybe they arrive at tons, megapascal, not on their, if you put down the budget and you say, oh, listen, you have also the background. You have the customers, 10, 20 years, 30 years. This customer told me that with the ballast, in 10 years, had this cost, construction and maintenance. The other customer had the slab track, mine, your, whoever, and in 10 years had this other cost, 2 numbers, 1 screen. You kill them. It's not a question, actually.
What's your shoe size? You want to be in my shoes?
No.
No. Yes, money directs things. Money can make things go ways. I think it's a combination. We talked about it in the lunch break.
Sure.
So it's a good point. I will take it with me. Maybe the next time we will talk, there will be better proof of these things. Still, I don't think that slab track is for all the tracks. That's my personal opinion. It's a special solution for a special problem. We don't need it everywhere. Doesn't make sense.
No, of course, of course.
And there's engineering reasons for it and cost reasons. Yeah.
What is needed is needed. Then you have the gray zone, and that's another play.
But be aware. Always think about the railway as a system. You have to cover all the aspects, from the labor, from the working, until the environment, until the system itself. So those are all things. You cannot make it black and white and say this is 50% more expensive than the other things, so that's why you have to do it this way. Then you would lose this, all the other aspects behind.
Let's say that it is not making black and white. What once you put on the place is something that part of the background that the final customer said, not you, not my opinion, because I'm going to sell. You have the final customer that put down the numbers, and if you don't believe you, they say, this is the reference, call them. They give you the same number. It is not black and white, but at the end, it is a good hint, I would say. Thanks a lot, sorry.
Okay, yeah, thank you very much. I will now close the podium's discussion, and I will come to some informations to you before we come to the farewell.
So, and first of all, thank you to our podium guests.
Yeah. So next steps, not in the development of slab tracks. Next step for us is a coffee break after the farewell, and then we will have a visit of the guided tour to the museum. I can understand that you will go to your home, to your family, and whatever. But I was during one break, I was a little bit inspecting the halls and the exhibition, and I would recommend you to stay here. It is wonderful. So then tomorrow, it starts at 16:30, so it's planned till 18, but I think it will not take time till 18 o'clock. So and tomorrow, on Saturday, we have this site visit to the metro stations. We will see something about this architectural design, but also about the technical issues. Hopefully somebody can explain us a slab track solution. Yeah, and it starts at 9:30, but I don't know where. Please, Charlotte, can you tell us?
9:30. Okay, I think Valerio can explain. Also for this evening, now, after the greetings and so on, you can visit free the museum. And if you want to leave your jacket and your bag until 5, there is the people who can stay with them. Otherwise, you have to take from now, from the finish the forum. And tomorrow it's 9:30 outside the station of Centro Direzionale. It's the station of line 1, Centro Direzionale. And if someone have to make a reservation, because there are some rooms. It's a very interesting visit. Yeah. Thank you for it.
Okay, thank you, Valerio. So, yeah, thank you. Now we say thank you to you, to our speakers and to our discussion people. Also, thank you to the whole Presidium and members of UEEIV, also to the Presidium and all the members from SCHIFI. Without the support of these guys, it was not possible to do this conference, but also many thanks to our sponsors. Without them, it would also not be possible to make such a conference. And of course, thank you to all helping hands, also here from the museum from Fondazione EFS. And molto grazie. Originally, the plan was to make different photos, one from the Presidium here, one from this group there, and so on. But we are not so much people at the moment, so I propose that everybody come to the podium and we will make a final farewell photo. Thank you very much for coming. Thank you for your time, and we'll be hoping to see you again in the next conference. Next conference will be held in Krakow, nearly on the same dates, I think around about 5th or 6th of November. Krakow is even same nice as Napoli, and the issue will be advanced technology and AI in railway infrastructure and rolling stock, something like that. Thank you, thank you, thank you. My angel now, it's like I've been awakened. Every rule I had to break it. It's the risk that I'm taking. I'm never gonna shut you out.